Hello, I'm Kiran Kumar from Nature of Physics. Today topic is wave nature of electron experimentally verified by the Davisson and Germer in the year of 1927. The deflection of the galvanometer is proportional to the intensity of the electron beam student. See there, this is the electron gun that produces the beam of electron which is incident on the nickel target, and diffraction electrons get collected by the movable collector student. Movable collector connecting to the galvanometer shows the current produced by the electrons. See there student, and the experiment is repeated by the changing voltage from 44 volt to 68 volt. Even graph also given clearly student. And the variation of intensity with angle of scattering phi is obtained for the different accelerating voltage. So potential is increasing from 44 volts to 68 volt, and we will get the different phi value. Phi value give the angle of scattering student. Phi value clearly given angle of scattering. Okay, and the current we will get maximum at phi is equal 50 degrees, and that corresponding voltage is 54 volts student. See there, first this is the incident beam of electrons, and theta is the angle of glancing, and phi is the angle of scattering student, and this is the nickel target, and this arrow mark represent the diffracted beam of electrons student. Okay, and clearly again we are discussing D is the thickness of the nickel target student. In this, theta is the angle of glancing, so opposite angles are same, so that opposite value we are getting D sin theta, and diffracted ray also making an angle theta student. Opposite angle C theta, C that is theta, and here the value is D sin theta we are getting, so that the distance travel in the crystal is taken as D sin theta plus D sin theta is 2D sin theta is equal to n lambda from the experimental value from the Bragg's law student. All the electrons not going to on point student, and all electrons are not distributed uniformly student. That's why the movable collector is connecting. That's why that is collect the diffraction electrons. Next thing is graphs between the angle of scattering and accelerating voltage student. First graph is at a voltage 44 voltage, and corresponding phi value that is equal to 30 degrees student. And next one, here voltage is increases from 44 volts to 48 volts student. Here the value we are getting phi value which is equal to 40 degrees student. And next one is, this is the value represent diffraction phenomena, central maxima, first minima, first maxima student. So here particularly the voltage is 54 volts student, and corresponding phi value which is equal to 50 degrees student. And next one, last one, here voltage from 54 volts to 60 volts student. There phi value we will get approximately 60 degrees student. See there, this is the third graph is most important according to the concept. Their current is maximum because of phi is equal 50 degrees centigrade and V is equal to 54 volts student. And next one, this is the representing incident beam of electron student, incident on the nickel target. These are the diffracted ray student, and D is the thickness of the nickel, D value which is equal 0.91 angstrom student. Okay, next one, the experimental value from the Bragg's law, so that is 2D sin theta is equal to n lambda. So first order diffraction maxima taken, n is equal to 1 student, first central maxima, then first maxima considering, that's why n is equal to 1 student. So that 2 into D value replacing 0.91 angstrom into sin theta value we have to find student. For this theta value, this is theta plus phi plus theta which is equal to 180 degrees student. Theta is the angle of glancing, phi is the angle of scattering student. So 2 theta plus phi which is equal to 180 degrees student. So 2 theta plus phi value by experimentally we got 50 degrees student which is equal to 180. So that 2 theta which is equal to 180 minus 50 is 130 student. So theta value 65 degrees I got student. So now I can replace here 65 which is equal to n is 1 lambda student. Okay, after solving this we will get lambda value is, that is 1.65 angstrom student. This is I can write as equation number 1 angstrom which is equal to 10 to the power of minus 10 meter student. Okay, and next one I'm going to explain the theoretical proof from the de Broglie hypothesis students. So de Broglie hypothesis equation lambda which is equal to h by p student, from the basic equation ke which is equal to p square divided by 2m student. So that momentum is equal to root over 2m ke student, but and ke value is equal to qv because of the basic equation v is equal w by q student. W is equal to qv student. W is I am writing as kinetic energy. This is now lambda which is equal to h divided by p value is replacing 2m ke student. Okay, and continuation next step is the values replacing ke which is equal to how much student, qv student. So that lambda which is equal to h divided by root over 2m q into v student. So that the values are replacing here. Now lambda which is equal to h value Planck's constant, that is 6.625 into 10 to the power of minus 34 joule second whole divided by root over 2 into mass of the electron 9.1 into 10 to the power of minus 31 kg, and next charge of the electron is 1.6 into 10 to the power of minus 19, and voltage we got 54 volt student. So after solving this we will get lambda value which is equal to 1.6 angstrom student. This I can write as equation number 2 student. So approximately equal value we got from the experimental value and also theoretical value. So experimental value is 1.65 angstrom and theoretical value is 1.66 angstrom. Both are almost same student. Please do like and subscribe our channel Nature of Physics.